Okay, Tom Siegfried's title of his talk is The Dice of Life, How Probability Rules the Universe, Society, and Science. From his abstract, Tom says, from atoms and molecules to life's evolution, to human nature and human society, and even the existence and properties of the physical universe, science's insights into nature mirror lessons learned from roulette wheels and flipping coins. What's going on here? Modern science, tracing back to Galileo and Newton, Copernicus, was defined in terms of strict causality. Means if this happens, then that will happen. Okay, so this is a clockwork causality. When a current state of affairs causes a subsequent state of affairs, it's repeatable, it's a unique state of affairs. So this happens, then that happens. Pierre-Simon Laplace famously gave us this image of science when he said, if you or a supermind could determine the position and velocity of all the particles in the universe, then at any given slice in time, then you would be able to predict everything that was going to happen in the future. Okay, that's the clockwork universe. Okay, that's the way it's supposed to be. Strict causality. This state will lead to that, will lead to that, will lead to that. Totally deterministic. That was the scientific model of the universe. Now everything's changed, actually reversed. For instance, evolutionary biologist Stephen Jay Gould asked the question, he said, let's go back 3.7 billion years on Earth and run the tape of evolution over again. Okay? So what reason do we have to believe we come up with the same outcome? Gould says zero, zip, none. Random mutation means that random. It could have been anything. They could have gone on, and the conditions were, there's nothing completely unique about the conditions of selection or whatever. So there's no reason. Maybe multicellular life would never even have evolved. Interesting. So no reason. Okay. So cosmologist John Barrow, in his book Constants of Nature, literally referring to Gould's question, says, well, wait a minute, what if we ran back the entire universe to the Big Bang and ran it forward? So what reason do we have to believe we'd come up with the same universe? We'd be sitting here talking, whatever. Barrow says none. Zero. Zip. Why is that? Partly it's because of chaos theory, but things don't. We thought everything, Laplace said it was all nice clockwork. No, there's chaos theory. Things muck around, okay? And quantum theory is in there with chance fluctuations. Stephen Hawking and his colleague Jim Hartle specifically point out, they say, like, because back at the beginning of the Big Bang, when everything was really small, quantum fluctuations were really dominant. So when the bang goes on, those fluctuations just magnify. So we can't really predict anything. So Brian Greene, actually in his book Fabric of the Cosmos, reflects on this. He says, scientists now appear to be in the worst possible position imaginable, because science is supposed to be judged on its ability to predict. But now, if we run these things back and we say, well, how can we predict? Given some particular beginning point, can we predict what's going to come out? And the answer is no, we can't. So Siegfried says, science's insights into nature mirror lessons learned from the roulette wheel and flipping coins. So what's going on here? I'm going to flip a coin here. Tails.